This is a question from the 2006 final. All right. There's this polynomial. It has integer coefficients. M over n is a rational root in lowest terms. What does it mean to be a root? Grayson? Yeah, so m over n is a root. That means f of m over n is what? Perfect. And it's in lowest terms. Is 12 over 6 in lowest terms? Okay. Is 19 over 4 in lowest terms? Okay. How about 16 over 6? Okay. So everyone knows lowest terms since grade 9, right? Anyone that doesn't know lowest terms? Speak now or forever hold your peace. Everyone knows lowest terms. Okay, good. So now prove that m divides e. Easy? Okay, I'm going to go through this fast because some people have already seen this proof because they came to my office hours. And it's a pretty easy proof anyway. So we're going to just plug in m over n is a root. So f of m over n equals 0, right? Okay, easy. What are we going to do next? Grayson? We could do that. Yeah, we can do that. I'm going to do that 2 steps from now. You can do that now or you can do that later. It doesn't matter the order. Versano? You can multiply. If you multiply by n, what's m over n to the 4 times n? Okay, so what can you do? It's a good idea. He doesn't like denominators. Neither do I. How are we going to get rid of the denominators? Hey, you guys know the answer already. How do you get rid of the denominator here? Come on, this is easy, isn't it? Versano.
You multiply by n to the 4.
Yes, multiply by n to the 4. Okay, we get this. Multiply both sides by n to the 4. Good. Now we do Grayson's idea. Subtract e from both sides. Actually, forget it. We're going to do that in the next. So here we factor out the m because we want to prove that m divides e, right? So let's put e on the other side and factor out the m. So we factor out the m. Boom. Here, we're done. And then we put the e on the other side, okay? Everyone's good? Okay, now we want to prove that m divides e. How are we going to do that? Paige.
We know that m doesn't divide n because the rationals in lowest terms.
Yes.
So it has to divide e.
Why does it have to divide e?
That's the only other thing that's multiplied by.
Okay, how many people agree? Marissa agrees. You have some loyal friends here. Anyone else? Maybe you agree, but you think it's not a good enough proof. Some people are now nodding their heads. Rest of the class is silent. Okay, so first of all, does anyone disagree that m divides negative en to the 4? Anyone disagree? No, because here I have negative en to the 4 equals m times a constant, and this constant is an integer. So everyone agrees with this. M divides negative en to the 4. That means m divides en to the 4. All right. So why do you guys disagree that? Why do you disagree with Paige? M does not divide n to the 4, right? M does not divide n to the 4. Does everyone agree with that? Does everyone know why m does not divide n to the 4? In the last class, someone didn't quite get it. Versano, you don't get it? M over n is in lowest terms. So they don't share any factors. Is 12 over 4 in lowest terms? Why? Because you can divide both numerator and denominator can be divided by 4. So if m over n is in lowest terms, you've already taken out all the factors. So m does not, m and n to the 4 do not share any common factors. M and n don't share any common factors. That means m and n to the 4 don't share any common factors. Okay. But now, m divides en to the 4, and m does not divide n to the 4. Does that mean that m divides e? By you nodding your head, you're confusing some people. Even Grayson's nodding his head. That's a mistake, isn't it? Well, so Grayson, m divides en to the 4, m doesn't divide n to the 4. Does that mean that m divides e?
Not necessarily.
Based on what? Why are you saying m divides en to the 4, m does not divide n to the 4? What are you using? DIC, transitivity? What are you using? why does it, why do we know that m divides e if m divides en to the 4 and m does not divide n to the 4? Transitivity. So that means if m divides en to the 4 and m divides.
I mean, I guess it's like the converse of transitivity.
Okay, so you think you can prove it using the converse? Yeah, how many people think that they can prove this? M divides en to the 4 and m doesn't divide n to the 4, then m divides e. How many people think that they can prove that if they were given 10 minutes at home? Okay, well, it looks like it looks pretty obvious, right? Like m divides this factor of two things. It doesn't divide one of the factors, so it has to divide the other factor, right? Seems like common sense. But if you try to prove it using the converse or doing some other technique, it might not work so well for you. Okay, so m divides e because m divides this and m doesn't divide that. But is the last step okay? And when you Google this, I say, okay, let me Google this. This isn't a theorem in the course notes yet. So A divides BC, then does A divide C? If A divides this product, then does it necessarily divide this C? Then first thing I find on Google is if the GCD of A and B equals 1 and A divides BC, then A divides C. That is a theorem. It's called Euclid's lemma. All right, so it is true. But when I look at the proof of Euclid's lemma, all right, so here's the theorem. If n divides AB and n is relatively prime to A, that means that n and A don't have any common factors, then n divides B. Okay, so this theorem that Paige is using, that is a correct theorem. Okay, it is correct, but how do you prove it? You go further down, you get the proof. Using Bézout's identity, you prove this. Have we taught you Bézout's identity? So if you use this on, if you said on the midterm, this is trivial, how do you prove it? We haven't taught you Bézout's identity, right? You can also prove it directly, but to prove it directly, you need to use strong induction. And these are the only two, I didn't have space to put the whole Wikipedia page here, but these are the only two proofs given. And if you look in the course notes, chapter 6.7, we cover Euclid's lemma there, and we don't give you any more proofs. Basically, you can prove it with Bézout's identity or with strong induction. Other methods, you can try it. You can try to prove the converse or something. First of all, just because the converse is true doesn't mean that the forward implication is true. You can try the contrapositive. You can try various things, but these are the two proofs that I was able to find. And they're not trivial, right? We didn't teach you Bézout's identity and we didn't teach you, well, we taught you strong induction, but it's going to take a long time. You have to prove it for n equals 1 and then n equals k, assume that it's true for n equals k, and then show that the fact that it's true for n equals k implies that it's true for n equals k plus 1. That's quite a lot of work. So even though this looks so trivial, if n divides AB and n and A don't share any common factors, then n divides B. It looks so trivial, but it's not, okay? Lesson number 1. Things that look trivial are not necessarily trivial. You actually have to prove it, okay? Once you start trying to prove it, you realize, wait a minute, is this theorem even true? Okay, that's part of this course. So who's ready to learn Bézout's identity? No one is ready to learn Bézout's identity. Okay, well, Bézout's identity is powerful because with Bézout's identity, you can prove this in one line. Well, a few lines, I guess, but it's powerful. It's able to prove the thing that no other technique was able to prove for us other than strong induction.